Hello, welcome to this channel Chemistry Made Easy by Dr. Ashok Mulik. In the previous lecture we have seen some part of this VSEPR theory. Now in this topic we will see the electronegativity and bond angles. So what is the relationship between the electronegativity and bond angles? First of all we will see here what is electronegativity. Electronegativity of an atom is the power to attract electrons from neighboring atoms which are bonded to it. In case of any example you will see here, so you can take the example like simple HCl. So here chlorine has power than hydrogen to attract electrons. So compared to hydrogen, hydrogen is less electronegative. So it will not be capable to withdraw electrons or attract electrons from chlorine. So chlorine is more electronegative. So chlorine will attract the bonding electrons towards it, that is from hydrogen. So this tendency or property of the atom is called its electronegativity. So this is a measure of atom's ability to attract the electrons from neighboring atoms bonded to it. So there are some examples of electronegativity values. Here you will find that the neon is most electronegative with 4.787 value. Then next is chlorine with 4.193, then followed by helium, oxygen, argon, etc. So these are the examples with decreasing order of their electronegativities. So these are helpful to us to predict about various properties of the molecule or various aspects about the structure of molecule. So trends of these electronegativities are observed in certain molecules on the basis of their effects in properties. So trends are observed in the periodic table. We can show this periodic table here in small form. Say this is our periodic table. So the groups are there like this, in which the electronegativities are highest at the top and these are decreasing as we move downward. So there are horizontal periods. So as we move from left to right in this period, along this period, the electronegativity values are minimum here, and as we move towards right, the electronegativity values are found to be gradually increasing. So the elements shown at the extreme right of the periodic table will have maximum value of electronegativity. So the trend of electronegativity shows in this way. So we can have some examples. You will find here the group 1 elements: hydrogen, lithium, sodium, potassium, rubidium and cesium. So you will find here the electronegativity values. Here you will see that the hydrogen has maximum value to 0.300 and followed by you will see that the values are decreasing as you move in downward in the group. Similarly, as you move in the along the group or period, along the period or row from left to right, you will find that the lithium is present at the extreme left in the row or period. So it has minimum value of electronegativity in this period. So it is followed by beryllium with relatively higher values, 1.576. Boron is next to it with still higher value. Carbon to next with higher value. In this way, the electronegativity values are found to be increasing as we move from left to right. So the extreme right element is a neon having highest electronegativity values. So these are important trends observed all over the periodic table. Now the next is molecules having larger electronegativity difference between central atom and outer atom have smaller bond angles. So you will observe here for some examples PF3, PCl3, PBr. So here you will find that the phosphorus is common everywhere. Then you will find that fluorine, chlorine, bromine are there. Out of these three, chlorine is most electronegative, next less electronegative is chlorine, and next less electronegative is bromine. So with this, the difference of electronegativity between that of phosphorus and fluorine is here maximum. So this maximum difference shows that the bond angles are smaller. You will find here in case of PF3 the bond angle is 97.8, in case of PCl3 the bond angle is 100.3, in case of PBr3 the bond angle is 101. So with here the difference is larger. So the larger difference shows a smaller value of bond angle. As this difference increases, here the difference is becoming lesser, the bond angle increases. Again here the difference of electronegativity between that of phosphorus and bromine again decreases, so the bond angle is found to be increasing. So this is the trend. Then you will find that next is atoms with larger electronegativity draws electrons from other bonded atoms. So you will find that there are many atoms such as OF2, OCl2. Here you will find that the atoms at here are oxygen are common. So fluorine and chlorine are different. So here the atoms with a larger electronegativity, fluorine is there. So this fluorine will draw electrons more from oxygen compared to that chlorine draws electrons from oxygen. So because of this, the bond angles are found to be changed in this way. So here the bond angle is less when the difference is more, because the electrons are drawn more from this oxygen. So these electrons are bonding electrons are moving towards fluorine. So the bond angle is relatively less. So here the electrons attracted towards fluorine are relatively less. Bonding electrons attracted towards chlorine are relatively less. So the bond angle is more. So in this way you will also find here the same case in case of NF3 and NCl3. Now the next point is effect of size. So effect of size, see the example of outer atoms here. So here you will find that the oxygen is common again. Size of fluorine is smaller, size of chlorine is larger. So what is the net effect? With increasing size of the bonded atom, the bond angle also increases. So in this case also the bond atom of fluorine is smaller than chlorine. So this bond is smaller than this bond. So with this you will find that the bond angle increases with the decreasing size of the outer atom. So fluorine, chlorine, these are outer atoms. So this will have impact on the bond angles. Next is in molecules containing hydrogen atoms, bonded or bonding electrons repel each other. So these are examples where you will find that the hydrogen atoms are outer atoms. So in case of water, so we are showing this example in this way. So oxygen is at the center and hydrogens are the outer atoms. So in such case, the outer atoms are bonding atoms are repelling the bonding electrons from each other. So here these bonding electrons are repelling each other. So here in molecules containing hydrogen atoms, bonding electrons are repelling each other. So here the oxygen present here is more electronegative. So this will attract electrons towards the oxygen. So it will withdraw electrons from hydrogen because it is more electronegative. Further, in case of H2S, the sulfur is also bonded to hydrogen, but the electronegativity of sulfur is less. So the electron attracting or withdrawing effect from hydrogen is less compared to this water. So because of this, the bond pairs are more close to oxygen. Here the bond pairs are relatively away from sulfur. So the bonding electron pairs which are lying closer to each other are repelled more. So the bond angle is more in water. In H2S the bond angle is relatively smaller because the bond pairs are slightly away from sulfur. So there is large or enough distance or space to position the electrons and the minimization of repulsive forces. So repulsive forces are minimized here because the outer atoms are hydrogen and the net effect is due to the central atom and its electronegativity. So here all these examples are also shown in this way. Here in case of PH3, SH3, the electronegativities are decreasing. So the bond angles are also decreasing in this order because the compared to phosphorus, arsenic is less electronegative, compared to this antimony is less electronegative. So in this case the electron pair is more close to phosphorus than that is observed in case of arsenic. So in case of arsenic the bond pair is relatively closer than that is observed in antimony. So the bond pairs are repelling each other, but the magnitude of repulsion between the bond pairs is decreasing in this direction. So the bond angle is found to be decreasing. So this is being called the effect of electronegativity and size. So the size of oxygen increases here and the electronegativity decreases. So these two traits, electronegativity increase and electronegativity, decreasing electronegativity and increasing the size, these are counter trends. These are balancing the effect on the bond angle. Because of this, the bond angles in these examples are found to be neither too large nor too small. These are rendered in between. So these are intermediate values of bond angles. Then next is when size of central atom, electronegative atom is smaller and the lone pair effect is more, the bond angles are larger. So here the central atoms are like this: nitrogen, which are in case of these examples of NH3, PH3, ASH3, SPH3, etc. Or you can take here OH2, H2S, which we have seen here, the examples like this. So the central atom is electronegative. So when the size of central atom is smaller, this nitrogen is smaller in size, but it is more electronegative. Phosphorus is larger in size. Compared to phosphorus, arsenic is again larger. Compared to arsenic, antimony is again larger. Similarly, oxygen is smallest, sulfur is relatively larger, selenium is again more larger, and tellurium is most larger in this series. So the bond angles are found to be larger with the central atom size of the central atom is smaller. And ligand pair effect is also similar. The ligand pair effect in case of nitrogen is relatively less, in case of phosphorus it is more, in case of arsenic and antimony it is also cumulative more and more. So that is why the bond angles are affected and found to be increasing. So with this we will stop here and we will see the remaining part in the next lecture. So please subscribe to this channel and press the like button and bell icon button. Keep watching this video and sharing this video to your other favorite friends. Thank you very much. See you next time.